This thing, I think I got everybody. But if you want to do the blitz, I'll be here tomorrow and Thursday. I'm really sorry about not being able to do blitz today. I asked if I could still do blitz. They told me no. And I'm required to go through sexual harassment training today. Yes, ma'am. Only if it's an NCFE or an EOC. Yes. Now, I'm not sure if we were supposed to actually watch the whole 14-minute video. So, really, you want to watch a 14-minute video on how to use the flags, the highlighters? Okay. I think I can find it in this. All right, here we go. All right, so number one, on the graph, what can you tell me about the solubility? Did it increase, decrease, or stay the same? It increased with temperature. Your graph should have gone up. All right, on B, we're going to have some variation here because you're estimating based on what your graph looked like. Hopefully, it's pretty close to what everybody else got, okay? So for the 35 degrees Celsius, what did you get? All right, here are 250. 260. What else? All I got is a 250 and a 260, nothing else? Nobody else did it. Renee, what'd you get? 260? Isabel, what'd you get? For the 35 degrees Celsius at B. You had 250? All right, so we're all there. What unit do we put on it? Grams per 100 grams of water. All right, for the 55 degrees Celsius, what do you have there? All right, I hear 400. What? 403. Nate's real specific over here. 403. What else we got? You got about 410? What you got, John? Okay, anybody else? Anybody got less than 400? Okay, so everybody got 400 grams per 100 grams of water. All right, 75 degrees Celsius. What you got? All right, I got a 550. 545. Anybody else? Passion, what you got? 550 grams per 100 grams of water. All right, if we do the temperature and C, this time I gave you 275 grams. What temperature did you come up with when you found the temperature? I hear 36 from Renee. Same thing. Anybody else get something different? No? All right, so 36. All right, in D, you're trying to figure out if they're saturated, unsaturated, or supersaturated. So there's two separate questions. You're plotting the points. So in the first one, you have 100 grams at 10 degrees Celsius. So if you plot 100 grams at 10 degrees Celsius, is it on the line, above the line, or below the line? So if it's below the line, what is it? All right, and in the last question, you have 325 grams at 35 degrees Celsius. Where is that at? Is it below the line, on the line, or above the line? So if it's above the line, it's what? It's supersaturated. Everybody there? Yes? No? Huh? We don't actually call it oversaturated. We just call it supersaturated. I think if you had written oversaturated, though, or thought that in your head, if it was on the exam, you would recognize supersaturated, Brandon. Okay? Anybody else question on homework? Feel okay about recognizing the answers on one of those graphs on the exam? Yes? No? Yes? All right. Let's talk concentration. All right. There's two formulas that go with concentration. So it would be great if we had more time to talk about it, but we don't. So we're just going to talk about the two formulas really fast. The nice thing about these two formulas, we have all the skills you need. So we just need to learn the two formulas. Let's forget them. I realize you have no phone to play with. However, that does not mean you can't pay attention. Okay? No, it's something old. Really? I just said it was something new. No, we're not reviewing yet. We're going to teach a little something new today, and then we're going to review. We're going to learn a little something new tomorrow, and then we're going to review. All right? So the first formula for concentration we're going to talk about is molarity. Okay? Yes. Molarity is defined as molarity equals moles of solute over liters of solution. Now, the nice part about this formula is it's on your reference table. It's about a third of the way down, maybe slightly more. So it's not one you have to memorize. Now, that's a whole lot to have to write down. So I like to shorten that into big M equals moles over L. It's a shorter way to abbreviate all that I wrote down. Now, sometimes students say to me, well, I'm going to get that confused with molar mass. No, you're not. Does this say anything about mass and pressure and temperature? No, you're not going to get confused with molar mass if you remember big M equals MRT over PT. You are not going to get these confused. This is going to talk about grams and volume. I'm going to give everybody time. Okay, so to solve a question like this, all right, what is the molarity of 125 grams of NaOH dissolved in 500 milliliters of water? Now, you have all the skills you need that you've already learned this semester to solve this formula. Molarity is what? Moles over liters. Okay, we're looking for big M. So what do I need on top? What do I always get a mole from? A gram. So I need to take this 125 grams and I need to change it into what? And then I need to take that 500 milliliters and I need to change it into what? That's my plan. Now, are either one of these two things we don't know how to do? No. You've long since learned how to do that. So we know how to do both of these things. Okay? So what do I do with that 125 grams? How do I do that if they give me that on the exam? Okay, one-step chart. So 125 grams. What goes on the bottom? What goes on top? What goes beside moles? That's right, because I have no balanced equation, right? So my grams, how do I get my grams? My NaOH. So Na, O, and H. 1, 1, and 1. Where do I get the masses from? So 23, 16, and 1. It is. I just said that in first period. Everybody's like, no, I need to know where it came from. So I didn't figure I should do that again. Guys, so 125 divided by 40. So what's 125 divided by 40? Anybody done that for me? Okay, I'll do it. No, not Johnny on today. 3.1 moles. All right. Now, what do I do with that 500 milliliters to liters? What do I do to change it? Okay. King Henry would have me dividing by what? You'd be dividing by 1,000, or you can move it 3 decimal places. So 0.5 liters. All right. So what's the last thing I need to do? I need to plug it in the formula and divide. So big M equals my moles, which is 3.12 moles over 0.5 liters. 6.2. That'll be, you can either write big M or you can write 6.2 moles over liters. You can do it either way. Some books like to use big M. I do because I can do it less work. Some books like to write moles over liters. It doesn't matter to me which way you do it. One is the same. Right? Right. We're talking about the second variety of problem you might get. Okay? Everybody got what they need. You can put either big M or moles per liter. Either one is the same. All right. What mass of C6H12O6 would you have if 7.5 molar and 150 milliliters? And let me change that to 1.5 molar. Did I not? Put the question mark down. Okay, what mass of C6H12O6 would you have if you had 1.5 molar and 250 milliliters? All right, so what's going to tell you on the exam if you see one of these what to do? That's right, okay? So as soon as you see this big M, like Anae said, that's right there is going to tell you need molarity, okay? So, big M equals moles over liters. So, what do we know? Big M is 1.5. What else do we know? And we're going to do what with it? All right, that's 0.250 liters. So we know that. So we're solving for what? And what are we going to do to solve for it? We're going to do what do we call that? To solve for it. What do we do to solve for it? I'm just looking for product multiply. Oh. Y'all are well down the road to solving for it. 1.5 times 0.25 gives me 0.375, and that's my moles, right? Now y'all can tell me what you were going to tell me a minute ago to find the answer. Now you're going to change the thing. All right, so what goes on the bottom? And then grams, and where do I get my mass? Can I just tell you it's 180? And you know where it came from? Okay. Oh, you did? Oh, I missed that. Sorry, I didn't hear you say it, but it's 180. I try to pick compounds I don't know. Just because I'm lazy that way. Question about molarity. Dilution is even easier. Huh? Molarity is done. You have all the skills you need to do dilution too. Huh? Nope. I look, you already remember we got those. All right, everybody got it? All right, last formula for today, and then we're going to do some review. All right. Another type of formula we use with concentration is called dilution. All right, some of y'all might be familiar with this. If you buy a frozen concentrate orange juice, personally, I don't care for that. But a lot of people like to buy frozen concentrate and then add water so that they can make stuff that way. Yep, a lot of people like it. I don't care for it personally, but a lot of people do like to do it that way. All right, I buy concentrated acids and I dilute them to the concentration we need here in the lab so that we can save money by not buying multiple bottles of just different concentrations of acids. So I do that. Okay, I just don't like juice that way. All right. So, what is the dilution formula? Again, on the sheet, don't have to memorize. M1 V1 equals M2 V2. Okay? M stands for what? And V stands for? Works just like the gas law. Okay? So the only thing you have to remember here is the units must do what? They must match. So it doesn't matter if you do this in liters or if you do this in milliliters. It's just like the gas laws were when we did Boyle's law and Charles' law. Okay? They just have to match. The volumes have to be in like milliliters, the volumes have to be in liters. So let's say, for example, I'm making an acid for the lab. How much? 12 molar HCl would we need to make 500 milliliters of 6 molar HCl. Okay? During the last lab, I had to make 6 molar HCl for the salt lab. Okay? I had to fill up a whole bunch of those little bottles. So I made a container of roughly 600 or 500 milliliters. Well, I had some left for next semester, but I needed quite a bit of it to be able to pour out for y'all to be able to use and then refill for fourth period for you guys. So, Alexis, you over there? Wait. Pay attention. So, when I did that, I took the 12 molar and diluted it. Now, sometimes in the word problem, they might use the word dilute. Did I use the word dilute? No. So how are you going to know to use the dilution formula if it doesn't say dilute in the question? All right, it gives you 2 molarities. That's one. The fact that there are 2 molarities there, certainly. The other thing is you have the same acid. That also tells you that it's a dilution because you're diluting that acid down, okay? Because the acid's not changing and you're changing it to a different concentration because the acid's the same. Now, all you have to do here is pretty much plug and chug. Same concept though. So it's another pair. So when you read this, you see how it says 500 of 6 molar? They have to stay what? Together. So it doesn't matter if you make them M1V1 or M2V2 as long as they're together. Okay? So when you plug them in, either side is acceptable. I'm just going to make them M1 and V1. So 6 molar and 500. And then my M will be 12. And I'm solving for V2. So 6 times divide 12, I get 250. So I would need 250 milliliters of that 12 molar to make the solution I'm making. Okay? No, the 250 is what you need. So that's what I would need to use the solution formula. Does that make sense? Okay, so that's all the new stuff I'm going to teach today. Tomorrow, if we have the full hour and a half, God helps us along, we don't have any bad weather tonight or tomorrow, I'm going to do about 30 minutes of nuclear because I can help you eliminate a whole bunch of wrong answers from nuclear in about a half hour. Okay? And then that's all the new stuff I'm going to teach. All right. All right, find your practice test. Oh, I know you didn't bring it or do it. Now, we're going to cruise through what we can. A lot of times I write notes out to the side and I use the questions as a springboard for other topics or things that we did. I don't just talk about the question as I do this. So feel free to write on your stuff or write down anything you want to know or you don't remember, okay? Some stuff we talked about the other day in review. Some of you were here, most of you weren't. So I might add in some stuff that you might not remember. Okay. It's okay. It's all right. It's okay. Now, so when you look at this, what can you tell me about the top number? What is the top number? Okay. Bottom number. Which one identifies the element? The atomic number. Everybody remembers that, right? All right. So what has to be the same to be an isotope? The atomic number. Okay. So which one of those questions says that? See, everybody okay with that? A lot of times they'll ask about isotopes. In order to be an isotope, the protons and the atomic number have to be the same. Now, just because we're talking about isotopes, what has to be different? All right, to be different, that would be the neutrons, or what other answer could they give you? Neutrons or you just told me the protons were the same. They can't be different. I just told y'all electrons are wrong. Y'all said neutrons. The other thing that neutrons are involved in. Yeah. Atomic mass are the two things that can be different. They can either say the neutrons are different or they can say the atomic mass is different. Either one of those two answers would be correct. The two things that have to be the same are the protons or the atomic number. Okay, those things have to be the same. Now, number 2. Which one of these would be correct for boron and carbon? A lot of times people read that question, I just read the question. Okay? Don't read the question about protons and neutrons without finding the answer about protons and neutrons. Okay? Most people have enough sense to do that. But every now and then I find students just read it and pick an answer. So when you're finding boron, this is boron half. All right, how many protons does boron have? The question's asking us about protons and neutrons. How many protons does boron have? It has 5. How many neutrons does boron have? It's got 11 right here, right? So 5 minus 11 is 6. Did you say 11 minus 5? 6. All right, so for carbon over here, how many protons does it have? All right, so to find the neutrons, we say, that's why I wanted to do this. Everybody always says 12 to me because we've been using 12 for so long. But it says what right here? So 14 minus 6 is 8. This is 14 minus 6. So now that you know 6 and 8, 5 and 6, now you can answer the question. Yeah. All right, an atom of boron has 1 proton, has 1 fewer proton, and 2 fewer neutrons. So does boron have 1 fewer proton and 2 fewer neutrons? Yeah, that looks like the answer. So let's look at the others just to make sure. Don't ever just go with the first one. Does boron have 1 fewer neutron? No, it's got 2, so that's out. An atom of, see, I could use an X there on my tutorial. All right, an atom of boron has 1 fewer proton. Yeah, it has 1 fewer, but it has 3 fewer neutrons. Nope, it doesn't have 3. An atom of boron has 1 fewer neutron. Nope, it's got 2. So A would have been the right answer. We could circle A. Okay? But don't just read. Find the answers and then solve. Yeah, I know. I got to fix it. Because it's not a smart notebook. All right, here is iron. And it's the electron configuration, right? The first thing I'd look at is iron has how many electrons? 26. Okay? So the first thing I'd do is, does everybody have 26 electrons? 2 plus 2 is 4, plus 6 is 10, 12, 18, 20, 26. 2, 8, 10, 16, 18, 24, 26. 2, 4, 10, 12, 18, 26. 2, 4, 10, 12, 18, 20, 26. All of them have 26, so that won't work for us. Okay? Sometimes that'll work. Okay? So that's the first thing. So now we need to look at the periodic table. Now, before I even go to the periodic table, is there anything just looking at it, you know, dang, that's wrong? Which one? That 1P. That 1P right there, for most people, jumps out as like, holy crap. Well, really, they put that there? We know that's wrong. Okay? Now, for a lot of other people, the rest of them, they don't jump out as holy crap, those are wrong. So now, let's remember what we know about the periodic table. Okay? So what starts here? 1s. So all of this is 1s. 1s, 1, 2. When we get here, we come around to this side. So this is number 2. This is S, 1, 2. This is 2s2. What's here? That's 2. This is P. P1, P2, P3, P4, P5, P6. So 2P6. Over here, we have 3, 3s, 3s1, 3s2. So 3s2, 3, and this is P. So 3P1, 2, 3, 4, 5, 6. So that's 3P6. We come over here, this is what number? That's 4s, 4s2, and then what number is right here? That's 3, and then 3D, 1, 2, 3, 4, 5, 6. That's 3D6. So the right answer is which one? It's A. Now, if I minimize that for just a second, now, when you open up the middle of your reference table on the test collection, okay, the first thing I would tell you to do when you open up your periodic table on exam day is put in your numbers. 1, 2, 3, 4, 5, 6, 7. 3, 4, 5, 6, 4, 5. 1, 2, 3, 4, 5, 6. Okay? So when you want to do iron, which is right here, you have 1. This is the S block, right? That's D. That's P. That's S down here. That's 1. This is S. That's 1. That's 2. And you get down here, back to this side. That's 2. That's S. That's only how many? That's 2. Then we have what number? What block? There's 2P. 1, 2, 3, 4, 5, 6. From there, over here, what number? What block? How many? What number? What block? How many? From there, 4. S, how many, Alexis? Okay. And then what number's here? D, and how many do I have? 1, 2, 3, 4, 5, 6. We stop there. Does that make sense? Okay, that's how we do it. But you can number that on your periodic table. You can write on those reference tables they're going to give you next Thursday. Okay? All right, how many electrons in the outermost energy level of aluminum? All right, what do they mean when they say electrons in the outermost energy level of aluminum? Outer shell, or what's the other word? Valence. How do we figure that out? All right, so group 1 has how many? Group 2 has, group 13 has. Everybody good with that? Yeah. If you don't know that, you don't want these things. Just like, there's no hope for you if you don't know that. Yeah. Did you not know that was 3? 3. Okay. Number 4. 5. 5. It occurs with light with wavelengths of 434 is emitted by a hydrogen atom. All right, what do we need to do this? Reference table. So turn to our reference table. What? I would be stunned speechless. Possible. Highly unlikely. Nope. Highly unlikely. Possible. All right, so 434. Sort of like being able to balance. Highly unlikely. All right, 434 is here. Follow it along. What does it go from? All right, 5 is right here. And it goes to 2, which is right here. Okay, now for it to emit light, like the question says. Okay, it says it emits light. So does it go down from 5 to 2? Or does it go up from 2 to 5? Because if you look at the question, it has both. It has to go down. So it has to be D. Okay, it has to go down. All right, number 6. Y'all are all very smart. This is one of the things I want to talk about tomorrow. Okay? Now, first of all, see how it says alpha decay right here in the question? You know it's alpha decay because it has this helium right there. That's what tells you it's alpha. It's one of the things I want to talk about tomorrow. But for the purposes of this question, y'all know how to balance and add. So this should be easy. The mass on this side is what? So the mass on this side has to equal 222. So it already has a mass of what? So 4 plus what will equal 222? What do you think? You have a number of 86. So 2 plus what will give us a number of 86? 84. Now, if you wanted to know the element that goes with it, what tells you the element? The mass or the number? So what element has a number of 84? That's how you figure out what the X is. Okay? You're just basically adding and making sure the number is equal on both sides. Okay? So, looking at the question, what is the mass number of the element represented by X? The answer is B. But it's one of the things I want to try to get to tomorrow, because this question is really pretty easy. About a half hour, and I can teach you most of what you need to know to do nuclear. Or I can help you eliminate a lot. That's what I'm going to try to get to. All right, number 7. We did this one in first period. They looked at me like, huh? Because they forgot the basics about bonding and the definition. If you remember the 3 parts to bonding, this is not hard. What can you tell me about ionic bonds? Not how to recognize them on the periodic table. Tell me their definitions of what happens to their electrons. This is the part people forgot. What happens in an ionic bond? The electrons do what? They're what? Yeah, that's not what I want. One of them is share. Tell me who shares electrons. Okay, there's part of it. All right, that's at least one bond. All right, so covalent equals shared electrons. All right, tell me about metallic then, since we seem to be struggling here with ionic. What happens to metallic electrons? They move freely, right? All right. Metallics move. That's the same as delocalized. When we talked about a metallic bond, we said those electrons are not attached to anybody. We called it the electron C model. That's what it means to be delocalized. They're not stuck on any one atom. They're able to move freely throughout the metal, which allows metals to do what things? What properties do metals have? All metals can do what? They can bend, they're malleable and ductile. What else can they do? I would not want to stick a metal object in that light socket. Why? They conduct electricity because their electrons are able to move. That's delocalized. Now, what happens to electrons in an ionic bond? We do the metallic, yes. I'm just going to have the definition on it. They don't share, so what happens to them? They what? Because we said they were lost or gained, right? So if you don't remember these three things, write them down. Ionic equals lost or gained, which is the same as transfer. Now, if you remember, who did we say was the weakest of those three? Covalent. So who of those three have the weakest or the lowest pulling point? Did you hear what Anae and Andy said? The weakest of the three bonds were covalent. So the lowest pulling points would be covalent. Who would have the highest pulling point? Metallic. Because they're the, don't choke on your side. Because they are the strongest bond. Now, ionic was sort of in the middle, right? Now, was it closer to metallic in strength or closer to covalent in strength? It was closer to metallic. They were still pretty strong bonds. They had a pretty high melting point. Who was brittle? Ionic was brittle. Now, given all of that we just talked about, which one of those answers would be correct when we compare ionic and metallic materials? All right, the bonds of a metallic substances are delocalized, yes, because they're able to move, and ionic substances are transferred. Yes, that is the correct answer. Okay? Now, D is wrong because it says metals are low melting points. No, covalents are low melting points. C, it says metals insulate. Who insulates? Who insulates? Covalent insulates. All right, number 8. Number 8's another one of those. I won't say you're not going to pass if you don't get it right, but number 8's another one of those that you should all be able to get right. How do we know it's A? Because you just know. I found out about the valence electrons, then somebody asked me what the answer was. So, how do we just know it? That's right. So, aluminum has an oxidation number of what? It is right here. 3. And sulfur is what? All right. So we got a 3, and we got a 2. 2 comes down, 3 comes down. That's why it's an A. Everybody good with that one? Okay. All right. What? Oh, okay. So which one would most likely form an ionic compound? All right. What do you have to be an ionic compound? Metal and non-metal. Everybody go with that? You got to be a metal and you got to be a non-metal. So if you got to be a metal and a non-metal, who are you going to be? Everybody good with that one? Yeah? You with me, Brandon? You just looking like you're going to nod off any minute now, the way you're nodding your head at it. Just be yelling at you like electric. All right? Number 10. All right. This requires you to remember bonding again, which is an accurate comparison of the bonds that can occur between carbon atoms in terms of bond length and strength. So, single, double, and triple bond. Who did we say was the strongest? All right, you can read the question. Triple is the strongest. All right, who did we say was the weakest? Okay, single is the weakest. All right, who do we say is the shortest? All right, triple is the shortest. And who is the longest? So that puts double in the middle, right? Even though we didn't say double, the double will be in the middle between triple and single for strength, and double will be in the middle between shortest and longest for length. So, reading those answer choices now. Based on what you just said, we need to find the one that is correct, okay? Which is an accurate comparison of the bonds that can occur between carbon atoms in terms of bond length and strength. All right, double bonds are shorter than single bonds. Are double bonds shorter? Yes, double bonds are shorter, because we said single bonds are the longest. But single bonds are stronger than triple bonds. Are single bonds stronger? No, that's out. All right, triple bonds are shorter than double bonds. Yes? And double bonds are stronger than single bonds. That sounds like it. Let's double check the others just to be sure. Double bonds are shorter and stronger than triple bonds. No. All right, and triple bonds are longest and strongest. No. All right, we're going to do 11 and then we're going to stop. Which one represents the formula for iron 3 chromate? Everybody agree with A? Okay, so iron has a Roman numeral 3. That means it's a what? Oxidation number, right? Chromate is CrO4 and it has a 2. Bring your 2 down. Bring your 3 down. And that's why it's... Everybody good with that? Yeah. If you have not finished all 40 of those, for homework tonight. Now, I want you to do the odd number on these. These are just some polarity questions and solution problems. Make sure we're okay on that. As far as I know, we're still playing by the same rules we always have. I have not been told otherwise, so I'm assuming the answer is no. I will check with Ms. Glass. But I have not been told otherwise, Sheena, so I'm assuming it's the same rules it always is. Okay? Put it this way.